Hello everyone, my name is Sethi. I hope you all are staying healthy. Today we are going to talk about two-variable regression analysis. Regression is about prediction. It helps to know how dependent variable influenced by independent variable. That means it helps to understand how dependent variable changes when we change independent variable. For example, fertilizer is independent variable, crops is dependent variable. Growth of a crop influenced by fertilizer, and farmer want to know how much more food they can produce by increasing fertilizer. How regression analysis help? Regression analysis help to find out point where adding more fertilizer stop giving extra yield. By doing this, regression analysis help to save money. Now we will see equation of two variable regression analysis. We represent two variable regression analysis through this equation. Here our dependent variable growth of crop and independent variable fertilizer. Yi dependent variable, Xi independent variable. Beta 1 intercept baseline yield, which shows how many unit of crop you can grow while using zero fertilizer. That means beta 1 shows natural soil fertility. Beta 2 represents slope coefficient. This is efficiency factor which mainly tell us how many additional unit of crops you can grow by adding one more unit of fertilizer. And mu I represent stochastic disturbance which shows influence of all other factor on growth of a crop other than fertilizer. That means mu I shows influence of rainfall, sunlight and soil quality on growth of crop but not of fertilizer. Population regression function is fundamental part of two variable regression analysis. Population regression function describe perfect relationship between two variables for entire group which you are interested. It describe whole population. That's why it is true model. For example, you want to know true relationship between study hour and exam score for all million students in country. So here you can see study hour is our independent variable and exam score is our dependent variable. We can present through this equation. Dependent variable, independent variable. This represent expected value of y for given x. This is intercept, we have already discussed. This one is slope coefficient, we have already talked about it. We can present population regression function through this graph. Independent variable study hours, dependent variable exam score. This line called population regression line, which is equal to this one, we have already discussed about this equation. Student who did study 10 hour receive 60%. Those study 15 hour receive 75. Similar you can see those did study for 20 hour receive 90% marks. And this point shows a conditional mean. And this curve shows distribution of score who did study for 20 hour, distribution of score who did study 15 hour, distribution of score who did study 10 hour. One most important thing, student who did study exactly same hour didn't receive exactly same marks. That's the reason we need to distribute their score. But why a student who did study same hour but didn't receive exactly same marks? Due to stochastic disturbance. Stochastic disturbance capture influence of other factor. For example, student marks influenced by their health, their concentration as well as their level of stress. Now we'll see sample regression function. This is also fundamental part of a two variable regression analysis. Population regression function describe entire population, but in real life we don't have so much time, resources as well as data in order to describe entire population. That means in real life we rarely have data about everyone. That's why we just take a small group or sample in order to estimate a value. When we take a small group or sample in order to estimate value, it will be called sample regression function. Equation is same. Dependent variable, intercept, slope coefficient, independent variable. Here we applied hat, which represent, we are not describing entire population. We just take some sample. EI represent residual. What is residual? Residual is difference, means vertical distance between actual observed data point and predicted value on regression line. This represent predicted value on regression line, and this represent actual observed data point. This difference will be called EI, or you can say that this difference will be called residual. Similar, you can see in this graph, this represent this one means predicted value in regression line, and this represent actual observed data point, and this vertical distance will called residual. Now we are going to talk about stochastic disturbance term. It is also very important for two-variable regression analysis. It captures influence of all other factors which actually affect your dependent variable but not include in your model. There are so many factors which influence your dependent variable, but it is not possible to include each and every factor in model. That's why we include stochastic disturbance terms. So we can say that stochastic disturbance terms represent all other variable which actually affect your result but not include in your model. For example, we cannot include every factor which influence human behavior. There are thousands of tiny factors which influence human behavior. How can you include each and every factor in your model? You cannot include stress in your model. You cannot include luck in your model. Second thing, human behavior is very unpredictable. Even same person behave differently every time. How can you include each and everything? That's why stochastic disturbance terms represent all other variables which affect your result but not include in your model. We clearly understand with the help of one example. You want to predict pizza price based on size, and your model conclude as size increase, price also increase. So this is your prediction according to this model. But when you actually go to pizza shop, you found pizza price vary even for same size. This differences arises due to extra topping, delivery fee, discount, coupon, or even human error. An error term, or you can say the stochastic disturbance term, capture influence of all other variable which actually influence your dependent variable but not include in your model. Formula to calculate a stochastic disturbance in case of population regression function. We have already discussed about population regression function. That's why we already know about this. So, stochastic disturbance, which is equal to actual observed value of dependent variable minus expected value. We can represent stochastic disturbance in case of standard linear regression model like this. We already know about all this term: dependent variable, intercept, beta 1, beta 2 till beta k represent slope coefficient, x1, x2 till xk represent independent variable, and mu I represent stochastic disturbance term. And we can calculate a stochastic disturbance in case of a sample regression function with this formula. Most important thing, in case of sample regression function, stochastic disturbance is our residual which is represented by EI. So formula to calculate EI: when you minus estimate value of a dependent variable from actual observed value of dependent variable, it will become equal to residual, and residual is stochastic disturbance in case of sample regression function. So this is all about today's video. I think you got it, and thank you so much for watching this video. Bye, take care.